Okay, in this video, I want to talk about compound events. And compound events in statistics or in probability is an event that includes two or more different outcomes. And before we talk about the specifics of the rules and the differences and when to use what, I want to start off with just saying, one thing I tell all my students, if you see the exact same problem, word for word, on the homework versus on the exam, that problem will be more difficult on the exam, even though it's the exact same problem. Now, what I mean by this is, if you think about doing math homework, you typically do one section at a time. So if you're taking a statistics course and you're working on probability and you're doing your homework, if you're doing homework from a section that's called the addition rule for probability, you don't have to think about what rule to use. You know every problem in that section, you're using the addition rule. And then if you're doing homework from another section called the multiplication rule, again, you don't have to think about what rule to use. The section is titled the multiplication rule. But if you see one of those problems on an exam, well, now the problems are all jumbled up. You don't know what sections they're coming from, so you don't know what rule to apply. So it becomes much more difficult on an exam. You have to know what to do before you could actually do it. If you're doing the homework from the section, just the name of the section tells you what rule to apply. So in this video, I want to talk about how to interpret a problem and decide when to use the addition rule versus when to use the multiplication rule. Now you'll see a bunch of terms scattered about on the screen right now. What I'm going to do is, let's start on the left. We'll start with compound event. So a compound event, like I said, is an event that consists of two or more different outcomes. Let's say, for example, let's say you're playing a game where you roll two dice and you win the game, you win the round if you roll a 7 or an 11. Well, the event would be you win, and there's two outcomes within that event. You roll a 7 and you win, or you roll an 11 and you win. So rolling a 7 would be one outcome, rolling an 11 would be the other outcome. Okay, so compound events, two or more outcomes. Now, whether to use the addition rule for a compound event or the multiplication rule for a compound event, it depends on, are these two events happening simultaneously or are they happening one after another? And that's really that's the key. That's the first big decision to make. Am I looking at one trial of an experiment or a procedure? So let's say one trial. Or am I looking at a sequence of two or more trials? So let's say multiple trials. Okay, so two or more events happening at the same time. And that's the key here. At the same time. Or are they two events happening one after another? One after another. And that determines whether or not we use the addition rule or the multiplication rule. Don't worry, we'll do a couple of examples in this video once we get through the determining when to use what. Now, if we're using the addition rule, if we know we're using the addition rule, we have to then determine, are those events mutually exclusive or not? Now, some textbooks use the word mutually exclusive. Some textbooks use the word disjoint. Let's go back to red. Some textbooks use one term, some use another term. These two terms mean the same thing. Mutually exclusive and disjoint mean the same thing. So, two events are mutually exclusive or disjoint if they cannot happen simultaneously. Okay, so let's say cannot happen simultaneously, which means, and I think the key here is no overlap. No overlap within the outcomes. And if the outcomes, sorry, we're talking about these two or more outcomes, if the outcomes are not mutually exclusive, they're not disjoint, that means they can happen simultaneously. So there is overlap. There is overlap within the outcomes. And now, if we're using let's look at the multiplication rule now. If we're using the multiplication rule, we have to determine, now this is in a sequence of events. Multiplication rule is the one we use when we're looking at the probability of one thing happening first, and then another thing happening second, and then another thing possibly happening third, and so on. So if we're using the multiplication rule, we have to be very careful in determining whether or not our events, or I guess we should probably say outcomes here, whether or not our outcomes are independent or dependent. So if two outcomes are independent, that means the first outcome occurring does not affect the likelihood of the second outcome occurring. So let's say for the multiplication rule, let's come over here and say we'll call A is the first event and B is the second event. So A happening does not affect the likelihood of B happening. Okay, so independent first outcome occurring does not affect, and the key word here is not, does not I can never remember if it's an A or an E in this case. I'll use A. Does not affect the probability. Does not affect the probability of second outcome. And if the two events are dependent, that means what happens first affects or determines the probability of what happens second. Say what happens first determines the probability of what happens second. Okay, so we've talked about how to determine when to use the addition rule, and that's if we're looking at one trial or we're looking at two or more outcomes, the likelihood or the probability of two or more outcomes happening at the same time, versus the multiplication rule when we're looking at what is the probability of one thing happening first and then another thing happening. Okay, so let's scroll down here. I've got a couple of examples, and I'm going to use a deck of cards. So I have 4 examples down here, and they're in order, one for each of these 4 scenarios up top. So I'm using number 1, number 2, number 3, and number 4 as an example of each. Addition rule with disjoint, addition rule with not disjoint, and then multiplication rule, independent, multiplication rule, dependent. Okay, so number 1. What is the probability that you pull one card at random from a deck? You pull one card at random, and that one card is either a face card or an ace. Okay, so for number 1, event A, or outcome A, is face card. And outcome B is ace. And we're looking for the probability of A or B. Keyword here is or. Or usually or is usually an indication that we're using the addition rule. Okay, so the event, the first outcome is face card. Second outcome is ace. Now, these two events are disjoint. They are mutually exclusive, because if you're pulling one card cannot be a face card, of which there are 12 of them, and an ace at the same time. One card cannot be both an ace or a face card. So it is simply the probability of A plus the probability of B. Now there are 52 cards in the deck, and there's 12 face cards. So the probability of A, the probability of a face card, is 12 out of 52. And the probability of B, the probability of an ace, is 4 out of 52, for a total of 16 out of 52. Now, if this was a question you were being graded on, we would reduce that fraction or put it into a calculator and get a decimal. Okay, so that's the addition rule with two outcomes that are disjoint. We have outcome A over here. We have outcome B over here. Okay, so now let's look at number 2. Same thing. Pull one card. You pull one card at random. Now for number 2, what is the probability that that card is either a face card or a heart? Okay, let's get rid of this. So again, we're looking at the probability of A or B. But the difference here is these events are not disjoint. There is some overlap. In the first example, one card cannot be part of outcome A and part of outcome B at the same time. But for number 2, face card or a heart, well, it looks like, let's use blue here. Here are the hearts. And there's definitely some overlap here. So you have 3 cards in the deck: the Jack of Hearts, the Queen of Hearts, the King of Hearts. So there's 3 cards that are part of outcome A and at the same time part of outcome B. So here is outcome B. And there are 13 cards in outcome B. So when we apply the probability rule, this equals the probability, the addition rule for probability, the probability of outcome A plus the probability of outcome B. So the probability of a face card, we know, is 12 out of 52. And the probability of B, the probability that the card is a heart, well, there's 13 out of 52. But we've got those 3 cards that we double counted: the Jack, the Queen, and the King of Hearts. So the Jack of Hearts is 1 card. It can't be part of the 12 and part of the 13. We can't count it as 2. So we have to subtract off the probability that a card is both part of A and part of B. So we're subtracting off the 3 cards that we double counted. And this is the this is the, let's switch to green, this is the addition rule for probability. And if your events are disjoint, meaning there's no overlap, that means the probability that the event, that the outcome is part of both A and B is 0. So for disjoint events, you could drop that last term. Okay? So it's 12 and 13 is 25 minus the 3 we double counted. So that is 22 out of 52. Okay? So if your events are not mutually exclusive or not disjoint, you have to subtract off the probability of one object in the sample space being part of both outcomes. Okay, so now let's talk about the multiplication rule. And in the multiplication rule, we're pull 2 cards, one at a time. Okay, pull 2 cards one at a time. So now, event A is the card is a face card. And event B is also the card is a face card. So face card first, face card second. Okay. So the key word here is with replacement, without replacement. So with replacement, that means we pull a card first, put it back in the deck, so then we have a full deck again, and then pull the second card. So for number 3, the probability of A and then B. A happening first, and then B happening second. Well, that should be the probability of A times the probability of B. And so let's look at the first outcome, the probability of A. Well, there are 12 face cards in a deck out of 52 total cards. So let's say we pull the Queen of Diamonds first. That's one of the 12 options. We pull the Queen of Diamonds. With replacement means we put it back in the deck, shuffle the deck, and then pull the second card. And so the probability the second card is a face card is not affected by what happened first. There are still, at step 2, we're back to 12 options for a face card out of 52 total. And we could put that into a calculator, 12 out of 52 times 12 out of 52, whatever that gives us is our answer. But if we now look at without replacement, so A is the first card is a face card. We pull a card. Again, let's say for number 4, probability of A and then B. Well, in this case, the probability of A times the probability of B given A. That's what this vertical bar means. This part here is pronounced probability of B given A. This is sort of shorthand for the probability of B given that A has already happened. And so this is the multiplication rule. This is the general multiplication rule. If the events are independent, then A doesn't affect B, then this probability of B given A just becomes the probability of B. But if the events are not independent, if the events are dependent, then, again, let's say we draw the queen of diamonds first. So the probability that A happens is still 12 out of 52. And this is what's referred to as conditional probability. Conditional probability. That's the probability of B given A. Probability of B given A has already happened. All that means is it's not, I don't want you to make it too complicated. The probability of B given A is the probability of B, and you just update your counting from step 1 in the sequence of events to step 2. And so, what I mean by update the counting, for the first step in the sequence, we had 52 cards and we had 12 face cards. But if we pull the queen of diamonds first, well, now there's no more queen of diamonds in the deck. That means there's 11 face cards left. So the probability that the second card is a face card is now the number of face cards in the deck, which are 11, divided by the number of cards in the deck. And since we took one out, there are 51 cards left. So notice the difference. With conditional probability or with dependent events, all that means is that at each step in the sequence, you have to update your numbers. You have to update your counting. Because remember, probability, the essence of probability is counting. And if your events in a sequence are dependent, that means the numbers change. Okay, so that about does it for this video. So let me scroll back up to the very beginning. I think this is where we started. The most important thing here was right here. Are these outcomes happening at the same time? In which case we use the addition rule, which is the probability of A or B is equal to the probability of A plus the probability of B if the events are mutually exclusive or disjoint. And if they're not, if there's some overlap, well then, sorry about that. Let's get back to full size. Okay, if they are mutually exclusive or disjoint, well then, say probability of A or B, the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B both happening. Okay, so this is the general addition rule. And for multiplication, the probability of A, say, and then B is equal to the probability of A times the probability of B. If your events are independent, or in general, the probability of A and then B is equal to the probability of A times the probability of B given that A has already happened. And so here's the general multiplication rule. And so for dependent events, the probability of B given A, well, A doesn't affect B, so that's just equal to the probability of B. Okay, that about does it for this video.